to the third part of the Newton law, students. In previous videos, we learnt about what are the Newton laws of motion, and also we learned the concept of the inertia and what is the normal force, normal reaction, and how to draw the free body diagram. In this class, we are going to learn about the concept of the apparent weight. The concept of the apparent weight, students. First of all, you have to understand what is the meaning of the apparent weight. Simply, apparent weight is the observed weight of a body. Apparent means what? Observed weight of the body. Before understanding this apparent weight, we must know what is the weight of the body and how it is different from the mass. As you learn that mass is the total matter contained in a body. The matter remains everywhere, and the units of mass are kilogram. Okay, mass of any body is same at all places. If you take them from any other planet or somewhere, the mass of the body remains constant. But weight is different. Weight is the amount of gravitational force acting on a body. Generally, we mistook the mass with the weight. Okay, but mass and weight are two different things. Weight is nothing but the gravitational force acting on a body. From where this gravitational force is coming? If you consider Earth as a complete sphere, okay, any body which come near to the Earth get attracted by it towards its center. Okay, that force is known as the gravitational force. The amount of gravitational force acting on a body is known as the weight. And you know that weight is the product of mass and acceleration due to gravity. Okay, students, if it is shown with the letter W, and you can write it as the mg. It's a shear force. Maybe the name is different. Weight is a force, gravitational force acting on body. We have to write the units of this. Obviously, it is kilogram meter per second squared, or we call it as the Newton. Okay, and it has the CGS units of gram centimeter per second squared, or we call it as the dyne. Not only these two, the weight is measured in kilogram weight also. Kilogram weight also, and we call it as a kilogram force. Kilogram force or kilogram weight. Okay, here kilogram weight means what? Just we have to multiply the mass with acceleration due to gravity. Okay, here is the weight. Now we are coming to the topic again. We are going to discuss about the apparent weight now. I said apparent weight is the observed weight of the body. How we observe the weight of the body, we have to understand. Listen me, students. You know what is this? Everyone is aware of this. We call it as the spring balance. Okay, students, and a scale is engraved on like this, okay, and it's suspended from somewhere and provided with a hook here, okay. Say it is suspended from a stand. This is the stand, okay students. Here I said it is engraved, okay, and it has a lever here. If you suspend anything here, the position of this lever will change. For example, you suspended some mass to this one, okay, it shows this reading. We call it as the weight of the body. Is the weight of the body, okay students. We took such kind of a stand, the stand what we took, okay, and we are going to observe the reading of the scale which is engraved on a keeping in a moving body. How the reading will change, does it change or not, and what factors the reading of the scale is observed, okay students. Here why did I write here WS? You know that it is the weight which is acting vertically downwards, and you know that a reaction will happen. This reaction we call it as a tension. This tension is shown in this scale, okay students. It's resting now. Then here the tension is equal to weight of the body, okay. The tension is equal to the weight of the body. Actually we are measuring the tension in the spring which is arranged in this spring balance, okay students. Here it is showing the weight of the body. If you take that reading and divide with acceleration due to gravity, you will get the mass of the body, okay. When you go to a bus station or railway station, you will see the weighing machines, and just you stand on it, and simply we can say our weight is 50 kg or 60 kg. It's not the weight. Actually we measure the normal reaction there. When you're standing on a platform here in this way, okay, it is provided with a scale or something. If you stand on, the weight will act vertically downwards, and this stand offers a force on you. There's a normal reaction. When you are standing on a weighing machine, you are not measuring your mass, but the normal reaction is shown, and you will get a paper. On that it will be printed as your weight is 60 kg. Actually it's not the weight, okay. It measures the mass. Actually what they did, they make an arrangement. They got the normal reaction and they divide it with the acceleration due to gravity, and we get the mass. Understanding students? Mass is the matter and weight is the gravitational force acting on the mass. The two things are different, okay. Now we are talking about the apparent weight students. What is the apparent weight? I told you it is the observed weight of the body. When we observe the weight of the body, we have several conditions here to observe the weight of the body, okay. One such interesting observation is a body is kept in a lift, okay students. The body is kept in a lift, okay. We are talking about the apparent okay. Apparent means observed weight. Let's say it's a lift students, Okay, it is resting over a surface. Okay, students, it's a closed capsule, isn't it? And provided with a rope here or the cord. Right now it is resting. What we are doing here, we are keeping the earlier experiment here in this one. Okay, by means of a stand or from the top. Okay, I suspended the spring balance. Okay, in this way it is engraved, I said. That means what it has readings over, and I hanged some weight. It has a mass of m. It is a situation, students. Okay, what we are doing, we are trying to find out the weight measured by the spring balance. With the help of that, we will find the apparent weight. Okay, now see, imagine it is resting. When it is resting, then what happens? The weight what we observe is equal to weight of the body only. There is no net force acting on the body. The weight is balanced with the normal reaction. I said the apparent weight of the body is equal to the real weight. Listen my words carefully. When the lift is at rest, okay, the apparent weight of the body is equal to the real weight. Okay, why it is? If the two forces are acting in opposite direction, if there is there is a force, net force, then we will get the net force is nothing but the weight of the body. Or is the force, isn't it? The difference must be a force. Fortunately, the weight or the apparent weight are the forces only. Here, when it is resting, the weight is balanced with the normal reaction. So, the apparent weight is equal to 0. Now think, this lift is accelerating. This lift is accelerating. Means what? It is moving up with a constant acceleration of a. Okay, students? Acceleration is acting vertically upwards, and you know that it is the direction of acceleration due to gravity. It is moving up means what? Some additional force is making the lift to move up. Okay, it is more than the weight which is offered by the body which is hanging in the lift. Here you say it is a force, I am saying it as the T. Okay, here it is making this one to move up. Then the weight of the body will act vertically downwards. If T is greater than the weight of the body, T is greater than the weight of the body, the difference between the two must be equal to the force which is applied. That means one force is acting. Actually, tension is upwards. Additional to that, we added one more force. That is, you can see here T is greater than mg. That's why it is moving up. Okay, students. The added force. That means T minus mg might be the force which is making the lift to move up. The difference, that is not net force. Then T can be written as ma plus mg, or we can say it is m of a plus g. Okay, students, if it was the reading of this spring balance, you will get the reading which is more when compared to the reading when it is resting. For example, you say, okay, the mass of the body is 60 kg. Okay, take G as 10 meter per second square, and it is accelerating up with an acceleration of 2 meter per second square. Okay, students, we have to find out the apparent weight. This thing I called it as the apparent weight. W apparent is equal to what I said, m of a plus g, 60 of 2 plus 10. It is 60 into 12. It is 720 Newton. Okay, let's check the weight when it is resting. Obviously, W is equal to mg. Okay, weight of the body when it is resting is equal to 60 multiplied with the 10, and it is equal to 600 Newton. Getting me, students? If you compare these two, W apparent and W, here it is in the case of the lift is moving up, you will find W apparent is greater than W. Here, what is W? W is the real weight. W is the real weight. Okay, students, the real weight of the body is greater than the apparent weight. Here, that's why when you are sitting in a roller coaster or in a giant wheel, when you are moving up, you feel some comfort. You will feel some uncomfort. That means we felt that our weight is increasing suddenly. That means we can't take the breath such easily. Okay, students, when the lift is moving up, the apparent weight, here if you take the example, it is 720 Newton. Means what we can write here, in this case when the lift is moving up, I said apparent weight is greater than the real weight. Is the first example. Okay, here in this case lift is moving up. Okay, if you consider the same thing, and we will get the same results. I took a man, here I took the reading. Okay, I found the apparent weight when a person is standing in the lift. Then lift is moving down with a uniform acceleration of a. Here I am showing the same thing. It's the same lift. This time this lift is coming down with an acceleration. Okay, students, in this case if you observe the reading, then what happens here? Okay, students, acceleration and acceleration due to gravity are acting vertically downwards. Means what? Here the weight, that means we are measuring the weight, okay, by means of a spring balance, which is a weight which is hanging, and we observing the reading of this. Here this weight is greater than the tension provided in. Okay, then we can write W minus T is equal to ma. Okay, one force is added, or simply you can say here downward forces, some of the downward forces are the weight of the body, and the force which is created by the lift is that it is given an acceleration of it. Then you can write apparent weight T is equal to W minus ma. As you know that W is equal to mg, it is equal to ma. We are calling T as the apparent weight. It is m of g minus a, and put the same values what we took here. Okay, it is the W apparent, and what we get? We are finding the W apparent by taking those values. M is equal to 60 as usual. Okay, into A. Here see G minus A. We took G as 10. It is 2. It is 60 minus 8. 480 Newton. Okay students, but what is the real weight here? Real weight is 600 Newton. Here apparent weight is less than the real weight. Understanding students? When the lift is coming down, the apparent weight is less than the real weight. Either you can take the mass which is suspended from the lift, what is that, the spring balance, or someone is standing here. Okay students? Then see the next case and the important case. Suddenly the cord of lift is, what is that, broken. Okay, what happens? It's falling. I am using the same relation. W apparent, we got it is equal to M of G minus A. And you know that any body which is falling under the gravity experiences an acceleration which is equal to acceleration due to gravity. In this third case, A is equal to G. Just substitute the values. M of G minus G is equal to 0. Okay students, here these are the three cases. With that we can understand what is the apparent weight is. Actually apparent weight is the observed weight. In simple words we can say, when the lift is moving up with an acceleration, the apparent weight is more than the real weight, because here one more force is added with the, what is that force which is pulling it up. Let the pulling force is T and one more force is added, then the summation of the two gives us the apparent weight of the body. Then lift is coming down. Either you can consider a person or the mass which is hanging in. You will get the similar results. And the third case, an important case. If suddenly the cord of the lift is broken, then what happens? Apparent weight of the body becomes 0. This state, okay, is known as the weightlessness. This state is known as the weightlessness. Weight has been, what is that, cancelled out. Okay, weight becomes 0. And one more case raises here. What happens? What could be the apparent weight? I think you understood all these things, students. In fourth case, what he is asking us, the same lift. Okay, listen, we are taking the same lift, and instead of acceleration, this lift is moving up with uniform velocity. Uniform velocity. What happens to the lift? See, generally W apparent can be written as, by considering these cases, M of G plus R minus A. Okay students, while moving up we can take it as M of G plus A. When coming down we can write it as G minus A. But what he is saying here, the lift is moving upwards or downwards with constant velocity, and you learn that constant velocity means acceleration is 0. Then W apparent is equal to M of G plus 0. It is equal to mg. That means what? We can conclude it as, when the lift is moving up or moving down with a constant velocity, the apparent weight is equal to the real weight. Here generally we travel in lifts. Okay, what I saw, what I observed, the velocity of the lift is kept constant. That's why they doesn't accelerate. So if we hang a spring balance added with some weight to the other end in a lift what we are using, you will get the similar results. Okay students, it is about apparent weight. Apparent weight means the observed weight of a body. Okay, we learnt about the different cases. In such case, in one of the cases, we find what is meant by weightlessness, and also what could happen. What could be the apparent weight of the body? The lift is moving with constant velocity. Okay, when the lift is moving with constant velocity, either in upward direction or downward direction, the apparent weight is the real weight. When it is moving with acceleration, apparent weight is more than the real weight. When it is coming down, the apparent weight is less than the real weight, and it is falling under the gravity. As you know that, we call it as the weightlessness. Students, I hope you understood this topic in a right way. If you like the video, please subscribe my channel